Hey everyone, for my topic presentation today, I will be talking about levers in biomechanics. But before I jump into the biomechanical aspect of levers, it's important to understand what levers are. So levers are a simple tool and they generally consist of a rigid bar resting on a pivot. Now, generally we refer to this pivot point as a fulcrum, but really levers are used to help move heavy or firmly fixed objects by applying pressure to one end of the lever. Now, it's important to note that there are different kinds of levers, but the example I'm going to be using today is a type 2 lever. And really the biggest thing with that is that when we're looking at the, the lever, in this case, it's my stick of wood that's going to represent something. A type 2 lever is the load and the work being applied is on the same side as the pivot point or fulcrum. A common example given for a type 2 lever is a wheelbarrow. So we're going to use my stick as a wheelbarrow example, but on one end we have the pivot or the wheel, which acts as our fulcrum point. We have the bucket that we fill up with our load, and then we have the handles on the other end that we're interacting with, and that's what we're applying the work to. So the work around the pivot point helps us to move the load in the center. And so that's a type 2 lever. Now, levers in the human body are the skeletal system. Muscles are applying the force or the work, and the insertion and attachment points are where that work is being applied. The load can either be an object that we're holding or just the weight of our body. And then generally the pivot or the fulcrum points are the joints. So it's really, really important, and the applications are numerous for levers in biomechanics because we are looking at the human body and how it moves. So my example today, and I'm going to be using the stick as part of it, I'm going to adjust the camera really quick. So part of my example today is I'm going to be using 2 sticks and a leash to illustrate a type 2 lever in the body. Now, a type 2 lever, right, we have the pivot at one end and the work and the load being applied on the same side of the lever. So in the body, the foot and ankle joint act as a type 2 lever, specifically the foot. Because we have the end of the foot or the ball of the foot that is acting as the fulcrum or pivot point. We have the work being applied through the Achilles tendon, and typically, right, it wraps underneath, but this is just an overly simplified version to illustrate a type 2 lever. And then we have the load in the middle. And now I have a second stick here, and this is going to apply or be representative of the lower leg, right, coming down. We would have the ankle joint here. And so as we go through that motion, we can see that the body is acting as the load on the foot. This would be the ankle joint, but then the work is coming from the same side as the load. And that ball of the foot or the end of the foot acts as a pivot or fulcrum point. And really, this allows us to have a mechanical advantage in motion. So that when we create, so it makes it easier to create motion by overcoming that mass. And if we overcome it fast enough, right, obviously it can kind of pop off, and that's generally applied in a jump. But the type 2 lever in the ankle gives us that mechanical advantage. So hopefully this gives you something to think about as you think about levers and their applications in biomechanics. Really, it's just the human skeleton, but we can look at that a little bit deeper and say, what kind of lever is this? How does it give us that mechanical advantage? And that's really going to help us understand the type of motions that they give us. So thank you for watching. That's levers in biomechanics.